This is going to be a really delectable question because there's so much going on. And so you can see the three sets of parallel lines. They say that ABCD is a parallelogram, and so immediately I know that this line is equal to this whole line. This line is equal to this whole line. The diagonals bisect. So this line is equal to this line. This line is equal to this line. So it gets quite busy, but yeah, let's see how we go. AF, they give us that AF to FD. AF to FD is 4 is to 3. We don't say it just as a number. We always put ratios. And then what I like to do is immediately get at least one other ratio. So here's a triangle that I'm looking at. And so if that's 4 is to 3, then this would be 4. Let's just use a different letter, is to 3. A lot of people would stop maybe just with this first ratio, and when you do similarity and proportionality, you probably often find yourself a little bit stumped. Others might go a step further and go, oh, if there's a ratio here, there's a ratio here, there is also a ratio here, that is to that. You could say 4Q is to 7Q. But I like to go a step even further so that I've got as much possible when I get to the question. So if this length AD is 7K, then BC is 7K because it's a parallelogram. If this whole length is 7M, then diagonals bisect. So this actual length would be 7M. And so I strongly encourage you, just fill in as much as you can before you get going with the questions. So that when, obviously you'd need to write all your reasons, sides in proportion, diagonals of a parallelogram bisect, that kind of thing. But for the point of this video, I'm just showing you talking-wise how you can get them, because when I get to the questions now, what's EM? At the moment I've got 3M is to AM, this whole line, that's 7M. And so the M's cancel, and I've got 3 over 7. What's CM? At the moment, I've got 7M is to ME. I've got 3M. Those cancel, and I get 7 over 3. And so with more information available, the questions that have always haunted you become a lot easier. This one's a bit of a funky chicken. And so the area of FDC is to BDC. So it's a bit awkward because they kind of cross each other. And so I'm going to show you a trick for this. What I'm going to do is I'm going to let this angle in FDC equal theta. And then because of co-interior, because I'm wanting an angle in BDC, this angle in the bottom here would be 180 minus theta, reason co-interior. When I do area ratio questions, I always go back to needing side, included angle side, and doing half base times height times sine of the angle in between. So watch how it looks for the FDC triangle. Half of, let me do it again, half of 3K times the other side would have to be CD times sine of the angle between over half of the base here, 7K, times the height, which would also be CD, because I need the angle in between, which is 180 minus theta. How does all of that help me? The halves cancel, the K's cancel, the CD's cancel, and the reduction of sine 180 minus theta just becomes sine theta, because it's in the second quadrant where sine is positive, and so on the bottom, on the denominator, we've just got sine theta. So these cancel. And so out of all of this, I'm just left with a 3 and a 7. And there's how you get a little bit of a trickier version of comparing the ratios of the areas. I hope you find it helpful. If you did, please like the video, subscribe to our channel, and share this with your friends.